In the last video, I talked about how to graph quadratic equations in vertex form. Today, we're going to be talking about how to graph quadratic equations in standard form. So just to recap, vertex form is y is equal to a times x minus h squared plus k. We like to have a parabola equation in this form because it's the easiest for us to graph, because we can just find the vertex by looking at it, and that's the most important point on a parabola is the vertex. From there, it's really easy to figure out the other points. Just by looking at this, we know that h comma k from the last video is going to be what our vertex is. So h is the number that's being subtracted inside parentheses, and k is the number that's being added outside of the parentheses. We could also, if it's hard for us to just immediately pull out that h comma k if we forget, we can always use the transformations that we know to find the vertex. So this is in a form where we can use the transformations that we know to find the vertex. So we know that if something's being subtracted inside of the parentheses, it means we're moving to the right, everything to the right, and if something's being added, we're moving to the left. The number we see added or subtracted outside the parentheses tells us how we're moving up and down. So those directions are going to tell us from the parent parabola where is our new vertex, because we're moving right or left and up and or down. From there, for standard form, the equation is y is equal to ax squared plus bx plus c. And we've seen this form a lot, but we haven't talked about how to graph it. And that's what we're going to do today. There are 3 different methods to graphing a quadratic equation in standard form. The first one is if it's factorable, we can factor it and find the x-intercepts and go from there. So the first method is you can find the x-intercepts if it's factorable and go from there. The second method is you can turn it into vertex form, which is the easiest form to graph, by completing the square. You can complete the square to get it into vertex form, to get the equation into vertex form, which is easy to graph. And then the last method that we could use is we could find the x value in the vertex by using this formula. X is equal to negative b over 2a. Once we find that x value, we could plug that in to our original equation, and that's going to give us our y value, so we have our entire vertex, and we can go from there. All right, so the first method, let's talk about the x-intercept method. The first step to doing the x-intercept method is, well, we want to find the x-intercepts, so we're going to take our standard form and we're going to factor it if it's factorable. So we're going to factor so we can find the x-intercepts, just like we've been doing. After we factor and find the x-intercepts, we're going to find the line of symmetry, which is the middle of those 2 x-intercepts, because that's going to tell us what our x value is in the vertex. So we're going to find the line of symmetry, or the middle of the 2 x-intercepts. And that's going to tell us the x value in the vertex. All right, and then the last thing that we're going to do after we find that line of symmetry, we're going to plug in the x value to get the y value, because we need to have the vertex. That's the most important point that we plot of our parabola. So we're going to plug in the x value into our original equation to get the y value. Okay. All right, so let's do an example. If we have y is equal to 5x squared minus 20x plus 15, we want to factor this thing. We know it's factorable because it's an example given to us that we can use the x-intercept method, and it needs to be factorable for us to be able to use this method. So first thing I always check when I'm factoring is GCF first, and all of these terms have something in common that I can take out before I do anything else. So all these terms have a 5 in common, so I'm going to take a 5 out. And that's going to leave me with 5 times well, x squared gives me 5x squared. I'm going to have, in parentheses, x squared minus 4x, what's wrong with me, plus 3. And then from there, I know that what's inside parentheses, I can find two numbers that multiply to 3 and add up to -4. So I'm going to do that using my diamond. Two numbers that multiply to 3 and add up to -4. And those two numbers are -3 and -1. So I'm doing the diamond to get to factored form from, or to further factor this. So I'm going to have, well, I don't need to write that in. I'm going to have 5 times, this is going to be x minus 3, because I know since a is equal to 1, I can go directly to factored form using those two numbers that I found. So I have x minus 3 times x minus 1 would give me x squared minus 4x plus 3. And then from there, I know that when y is equal to 0, so when y is equal to 0, because this is my equation equal to y, I know that one of those factors has to be 0. So I could either have x is equal to 3 or x is equal to 1, because x minus 1 has to be equal to 0 or x minus 3 has to be equal to 0. So my x-intercepts, that tells me my x-intercepts, and my x-intercepts are when y is equal to 0, are 3, 0, and 1, 0. So I have my x-intercepts, and I can plot those. Those are 2 points on my parabola. So I'm going to plot them. I have 3, 0, and I have 1, 0. And then what I want to do from there is find the middle between them, because that's going to be where my vertex is, since I know that parabolas are symmetrical. And these have the same y value, so they're going to be symmetrical points. So the middle of those 2 points is this line here, and that line is going to cut through the vertex. So I know my vertex, since this line of symmetry covers all values where x is equal to 2, I know that my x value and my vertex is going to be 2. So x is equal to 2 is what I'm going to have for my vertex, and then I just plug that into my original equation, except I want to use this one because it's easier, so I'm going to use the factored form. I'm going to do y is equal to 5 times, everywhere I see an x, I'm replacing it with 2, so I'm replacing it with 2, and then I'm going to get 5 times -1 times 1, which gives me -5. So my vertex, I know then, is 2, -5. And I'm going to plot that. 2, -5. 1, 2, 3, 4, 5, down here. And then I just connect the points. So in a curved shape, because I know this is a parabola, since I have x squared. Right? And that's as symmetrical as I can get it. That is my parabola. Did I forget anything? No. I just like to color, I'm going to color code the vertex to be blue every time. All right. That's the first method. So, I want you to try this example on your own. You can pause the video and do that. All right, so what you should have done first is you should have taken out a 2, because that's the greatest common factor. So it would have been 2 times x squared plus 6x plus 8 when you did that. And then that would have factored further to, if you use your diamond, you can find two numbers that multiply to 8 and add up to 6, and that's 4 and 2. So you have 2 times x plus 4 times x plus 2. And that's going to give you y is equal to, oh, I'm so sorry. So from there, I'm going to find what my x-intercepts are. So I know when y is equal to 0, I have x is either -4 or x is equal to -2. That tells me in my x-intercepts, since I know that when my y is equal to 0, that's my x-intercepts. I have -4, 0 and -2, 0. So that's my x-intercepts, and I can plot those right now. And -4, 0 right here, and -2, 0 right here. From there, I want to find the middle between them, because that's going to be where my vertex is. So the middle between them is this line here, and that's the line of symmetry which goes through all points where x is equal to -3. So that means in my vertex, x is equal to -3. And I'm just going to plug x is equal to -3 into my factored form. So I have 2 times everywhere I see an x, I'm replacing it with -3. And that's going to give me y is equal to 2 times 1 times -1. And that gives me y is equal to -2. So my vertex is going to be -3, comma, -2. And I plot that. -3, -2 right here. And then I have my parabola. I'm done. This is my vertex. All right. Next method is completing the square method. So the completing the square method, we're going to change our equation into vertex form. So the first step to doing that is we're going to focus, just like before, we're going to focus on, it's just a little bit different than what we did before, x squared and x. And then focusing on that, we're going to take out the GCF only for x squared and x terms. Take out the GCF, if there is one, because there always isn't always one, only for x squared and x terms. The second step is we're going to complete the square inside parentheses. So once we pull out that GCF of just the x terms, we're going to complete the square inside of the parentheses. Or complete the square for just the x squared and the x. Complete the square inside. I always spell this wrong. I think it's parentheses. All right, and then the last step is we're going to subtract the same amount that we added to complete the square. We're going to subtract it outside of the parentheses to keep the equation balanced. So subtract the same amount that you added to complete the square outside the parentheses. All right, so let's do an example, because that's probably a little confusing if we don't do an example. We have the equation y is equal to 3x squared plus 12x plus 15. The first thing we always check is if we have GCF, and we have a GCF here between, and we're only focusing in on the 3x squared and the 12x, just the x terms. So we have y is equal to, we're going to take out the GCF of those two terms, which is 3. So I have 3 times x squared plus 4x plus 15. I'm leaving the 15 by itself. Then what I'm going to do from there is I'm going to complete the square inside of the parentheses. I'm going to complete this square. So I just only took out the GCF of those terms with x squared and x, and now I'm going to complete the square inside of the parentheses. So I have x squared plus 4x plus something, because I want to be able to get this into vertex form, so I need some expression to the second power. And I'm going to be able to factor this. If I complete the square, I'm going to be able and make it a perfect square trinomial. I'm going to be able to factor it to be some expression times itself. And whatever number I add there, I'm going to subtract outside, or whatever value I added to the entire right side by adding something here, that's what I'm going to subtract. The number that I have to add to make this a perfect square trinomial is, well, to find p, I do the number in front of x, which is 4 divided by 2, so that's 2. I know I want this to be x plus 2 squared. And in order to do that, if I FOIL that out, I would see that this term is just 2 squared, and that would give me that I'm adding 4 here. If I add 4, what I really am adding to the right-hand side is 3 times 4, which is 12. So if I'm adding 3 times 4, which is 12, that means outside of the parentheses, I need to take away 12 to keep it balanced. And then what I have on the outside of the parentheses when I simplify is 15 minus 12, which is 3. So this is my vertex form. I have my vertex form now, and I can go from there. And we already know how to plot a parabola when we have vertex form. So the first thing I'm going to do is find, well, what's my vertex? I know my vertex is going to be what's being subtracted inside of the parentheses is my x value, so that's -2. And my y value is what's being added outside, so that's 3. I have -2, 3, that's my vertex. So I'm going to make it blue. That's my vertex. And then from there, I just have to plot one point. I use a mini table to plot one point to the right of that. And then I can use the line of symmetry to plot the other point. So I'm going to pick -1, since that's right to the right of it. You usually want to pick the point right to the right of it, the whole number point right to the right, because it's exponential growth, so it might not fit on your graph otherwise. So I'm going to plug that in. Y is equal to 3 times -1 plus 2 squared plus 3. That gives me 3 times 1 squared, which is 3. 3 plus 3 is 6. So I have -1, 6, which is right here. And then if I use my line of symmetry, so if I use this line of symmetry here, that tells me that my other point, this point is 1 away on the right. So my other point, symmetrical to that, will be 1 to the left of the line of symmetry. And this is my parabola. And I'm done. All right. Next, I want you to try this completing the square method problem. So pause the video and do that. All right. So what you should have done first is you should have taken out the greatest common factor of just the first two terms. So I'm just looking at the x squared and the x. So you should have taken out a 2. So 2 times x squared minus 4x plus 7 is what you would have had. And then from there, you want to complete the square inside of the parentheses. So x squared minus 4x, and we just did an example almost exactly like this. So we should know what number we have to add inside. Whatever value we've actually added to the right side, we need to subtract that value. So I know that it's completing this square. -4 divided by 2 is going to tell me p, and that's -2. So I really want this to be 2 times x minus 2 squared. And I know that that means -2 squared is what goes here, and that number is 4. What I'm actually adding to the equation on the right-hand side is 2 times 4. So 8, which means I have to subtract 8 outside of the parentheses. So I'm going to have 2 times x minus 2 squared minus 1. And that's my vertex form. So this is my vertex form. So that tells me my vertex is going to be 2, -1. Just pulling out h and k. 2, -1 right here. That's my vertex. I'm going to make it blue. And then I just use a mini table. I just need one point, and I can use the line of symmetry to find the other point. So I'm going to pick x is equal to 3, since that's 1 to the right. And I'm going to plug it in. I have y is equal to 2 times 3 minus 2 squared minus 1. I know 3 minus 2 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So this is 3, 1. If I use my line of symmetry, which goes the vertical line that goes through the vertex, I know that that point that I just plotted was 1 away on the right. So the other point, symmetrical to that, would be 1 on the left. And this would be my parabola. All right, and the last method that we're going to talk about is the -b/2a method. The first step to that is we're going to use that formula. This is a formula. So x is equal to -b/2a to find the x term in the vertex. So that's just going to immediately tell you the x term in the vertex. From there, you're going to plug the x term in to find the y value in the vertex. So you're going to, into the original equation, plug in the x term to find the y value. Of the vertex. Okay, and then the last step is to make a table and use your line of symmetry to find the other points. So make a mini table to find, make a mini table and then use line of symmetry to find other points on that parabola. All right, so first step, if I have, I was supposed to give an example here. If I have the example, y is equal to x squared plus 6x plus 2. If I have that example, the first thing I'm going to do, so step 1, I'm going to use this formula to find my x value. So I know the x value in the vertex is going to be, I'm going to take negative b, and negative b in this case, well, let me just label what I have. A is equal to 1 here, b is equal to 6, and c is equal to 2. So I'm going to do negative b, which will be negative 6, all over 2a, so 2 times 1. And that's going to give me my x value in my vertex is negative 6 over 2, which is equal to negative 3. So x is equal to negative 3 in the vertex. Step 2 is to plug that in and see what I get for y. So I have y is equal to negative 3 squared plus 6 times negative 3 plus 2. And that gives me y is equal to negative 3 squared is 9. 9 plus negative 18 plus 2 gives me y is equal to negative 7. So y is equal to negative 7 in the vertex. So I know my vertex then is negative 3, negative 7. And I plot that, negative 3, negative 7, which is right here. That's my vertex. And then I use a mini table to find just one other point. So let's use x is negative 2. When I plug that in, I get y is equal to negative 2 squared plus 6 times negative 2 plus 2. I'm plugging negative 2 into the original equation. And that gives me 4 minus 12 plus 2, which means y is equal to negative 6. So that's negative 6. And then I plot the point, negative 2, negative 6, which is right here. If I use that line of symmetry, which goes through the vertex, I know another point I can plot is 1 to the left, where y is equal to negative 6. I connect these two, or all of these points in a curved fashion because this is a parabola, and I'm done. All right, I want you to try it. Pause the video and try this example. All right, let's go over this. I have y is equal to x squared minus 2x minus 3. So the first thing I'm going to do is I'm going to find my x value in my vertex. So x is equal to negative b over 2a. The a in this case is equal to 1, b is equal to negative 2, c is equal to negative 3. So I'm plugging in, I'm doing negative and negative 2, since b is negative 2, and then I have that over 2 times 1. And that gives me 2 over 2, which is 1. So x is equal to 1 in the vertex. And I'm going to plug that in to my equation to find the y value. So I have y is equal to, I'm using this equation, y is equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1, 1 minus 2 minus 3. That gives me a total of negative 4. So y is equal to negative 4. Then I know my vertex is going to be 1 comma negative 4. I'm going to plot that 1 comma negative 4 right here. That's my vertex. And then I'm going to use the mini table to find one other point. So I'm going to do 2. And then I plug that in. So I have y is equal to 2 squared minus 2 times 2 minus 3. That's 4 minus 4 minus 3, which gives me negative 3. 2 negative 3 right here. And then I know that also means that I have 0, negative 3. And I connect these, and that's my parabola.